So for these noble gas notations, the goal is to take a long electron configuration and shorten it. So it saves us time, but more importantly, it helps us focus in on the most important electrons. So lead was the first example I did because we already wrote out the full electron configuration for lead. When you're using the noble gas notation, you need to find your element on the periodic table. Lead's just over this shoulder right here. Then go up a row, and when you go all the way to the end, you'll find the last noble gas, or you'll find the noble gas there at the end of that row. In this case, it's xenon. So xenon has 54 electrons, and what's important about that is that it fills the S and the P sublevels up to the row that it's in, up to level 5. So what we need to do for lead is after we've written the xenon is start at the beginning of the next row. So that's over here. So that with cesium and barium, they fill the 6s sublevel. So when we look to do a noble gas for something like lead, we're always looking at, well, it's in row 6, so I'm going to start in 6 over at the beginning, and that's the 6s. Remember with these, right here is where we get lanthanum and actinium, or we go down to the F sublevels. So then we still have our Fs, our Ds, and our Ps. And to remember, xenon is 54 plus 2 plus 14 plus 10 plus 2 adds up to 82. Right here for francium, francium's got 87. It would be a whole lot to write, but the nice thing here is that it is a alkali metal. It's right there in the first column, so it only has one more electron than a noble gas. This is a great example of how noble gas notation really helps us focus in on those very important reactive elements. So we've got 7s1 because this is in row 7. The first thing we always start with is the S, and francium's in column 1, so it just has that 1. If we were coming back here to lead, it is important to notice we would show all of this, but really the most important ones are the ones in that highest level. So there are some in levels in the 6s sublevel, the 4F14, the 5D10, the 6P2. We can see all of that, but it's really the stuff in level 6, the 6S 6s2, excuse me, and the 6p2 that are most important. These fill after that, but they are parts of levels 4 and levels 5. So we'll see down here, when lead is doing anything in terms of its reactions, it's those S's and P's in that highest level that's most important.